The last topic for today's lessons, we introduce the concept of earned value analysis. And in the next lesson, we apply this earned value analysis to evaluate the project status. So what we have gone so far in the project control, including the method that we discussed in the work time relationship, and we apply that in problem 1 and problem 2 for today's class. We estimate percent complete at the unit of measure throughout the task. Percent complete can be measured by the percent of budget spent, the physical work completed itself, or the percent time spent. So all of that, they are subjective and insufficient. When we say the budget, we ignore the work completed. When we say time spent, just like problem 2 we did in the previous lesson video, it will be subjective and insufficient because the rate of work may not be linear from time to time. So with that, when the input percent complete are subjective and insufficient, we may provide a misleading conclusion. For example, the project may be or actually behind schedule with our estimate percent complete. Finally, we may say that it ahead of schedule. So that may be a misleading conclusion. So that use unvalue analysis may help in that scenarios, and that is the purpose for the remaining of today's class and the next class, unvalue analysis. So what is that about? It be able to unvalue method or analysis, EVA or EVM, answer to multiple management questions. Are we ahead or behind schedule? Something we did in problem 2 in today's class. We can be able to answer that question. Unvalue method can be answer that question as well. Are we ahead or behind schedule? And then how efficiently are we using our time? So that something the work time relationship may not be able to answer. In the earned value method, we can be able to answer that question. When is the project likely to be completed? So we can forecast now, given the current state of project, when should be project completed, so that we can forecast the project time. Are we currently under or over budget? So we can assess the current status of the budget, of the cost of project. So work time relationship only be able to estimate the time, but for the unvalue method, we can be able to assess the cost status, the budget status of project, over or under budget. And then how efficiently are we using our resources? So not only how efficiently we are using our time, it only also the resources we can be answered with the unvalue method. What is the remaining work likely to cost? So that we can see that, okay, with that money we already spent, how much money we needed for the remaining work, for the rest of the work. We can be able to answer that question so that we can prepare the resources necessary to complete the project. And then we can be able to forecast with that stated, with the actual cost that we spent so far for the project. What is the entire project likely to cost? The whole project cost. So that is the forecast of project cost. So that with one method and value analysis, EVA, we can be able to answer multiple questions with different metrics, and that we are going to answer this question in the project in the next lesson. But first thing first, we need to introduce a few basic parameters that very important for unvalue method. And before we apply, I urge you to review this basic element that we are going to talk very carefully, and be able to determine that and apply that in problem 3 of today's lessons. And of course, question 8, how much will we be under or over budget at the end of the project complete? So what are the basic elements of EVA that I'm going to discuss today? The first is plan value, PV, earned value, EV, and actual cost, AC. So don't think AC in this class is actual cost, not air conditioning in the real life that you may heard when we talk about the weather or the temperature in the house. And then with that one, we have the budget at completion, BAC. It represents the total plan value with the PV, the one here, for the whole project. So that is the budget at completion. The total plan value, we consider that is the BAC, budget at completion. So let's talk about these three elements, basic elements, and that is the purpose today. Need to differentiate. You need to see the differences between these three basic elements: PV, plan value, EV, earned value, and AC, actual cost. Before, we need to go to the definition of those three elements. The first is the plan value, PV. It describes how far along the project work is supposed to be at a given point in the project schedule. So that is your plan, how far along to be at any given point, after 6 months, after 1 year, or after 1 month. So that is at any given point on the project schedule. So far, you already know how to develop project schedule. Now, when the project in progress, we want to know at certain point, we want to stop and we want to see what is the project status, then we need to know the plan values. And that is a numeric reflection of the budget work that is scheduled to be performed. So it's budget work, so it means that it measures about the money involved for the work that is scheduled to be performed. So you plan to perform as of, let's see, after 5 months, perform that much based on your schedule. So that is plan value. It measured by the budget, measured by the money. And in the past, plan value also called that a budgeted costs of work schedule, BCWS. So that is the plan value. Everything is about plan. The work also plan, the budget also plan, that is plan value. The second parameters is earned value, EV. It's a snapshot of the work progress at a given point in time. Let's see after 5 months, what is the snapshot of work progress? How it measures, it reflects the amount of work that has actually been accomplished today, expressed at the plan value for that work. So as you can see, the work that has actually been accomplished or completed, it means that if the work is actually completed, but it's spread in the plan value, so with plan budget, that called earned value, and also known as budget costs of work performed. So that is earned value. It reflects the work is actual and the plan for the money, that we call it earned value. The last one is the actual costs, is an indication of the level of resources that have been expended or spent to achieve the actual work performed today. So as you can see, the resources actually spent, so the actual money already spent to achieve the actual work. So it means both are actual, work are actual, resources, money are actual spent, then we call it actual costs. And that is also known as actual costs of work performed. It's still abstract. Let me go back to the note that I have something that very easy to remember and be able to apply. So now we talk about the three elements, PV, EV, and AC. Then we have two things that we need to consider: the work and the budget or the cost. In the work, we can have planned or actual. In the budget or cost, it's planned or actual. If both work and plan for the cost also planned, so work are planned, budget are planned, then that is the plan value PV. If the budget is planned and then the work are the actual, then it called earned value. So the earned values measured by the actual work that we accomplish compared to the planned budget that we achieve. So that if you sign a contract, the client doesn't care how much money you spend for the project. It's only paid based on the contract, and that considered at the earned value. Earned value. So it means you see how much I achieve based on the contract, is how much I earn. So that is the earned value, and that earned value is not necessarily the same as actual cost spent. If you earn more than you spend, so EV more than you spend AC, then you are under budget. If you earn less than what you spend, EV less than AC, then you are over budget. So that is the actual the earned value. And then the last one is the work is actually accomplished, and the monies or the cost or the budget is actually spending, then it called AC. So that's what we have for PV, EV, and AC. So for control project, I just give you one example here. And you can see when we talk about percent complete, etc., how the real life project look like. This is the Duke Energy IGCC power plant project in Edwardsport, Indiana. So as you can see, we have the report, and then the overall, you have the actual completed, the baseline, the plan completed. So we can be able to know how much we are behind or ahead of schedule. In this case, actual completed, and can be break it down into engineering work. So far, we supposed to complete 94%, and now we actually complete 93.78%. Similar for procurement and construction. And go back to further, they have 48 page of analysis. And in terms of the cost, something that we are talking about, for years project, we can be able to see the control budget, $886 million. They actually spent invoice today, 246. Forecast, so that you can see you have the progress, construction progress of the plan, 83%, 38.75%. Forecast, 35.58%. The actual is 34.29%. It means the actual less than the forecast or plan. It means we are behind schedule, and the cost as well, as you can see there. And be able to develop a curve, and you can see that with time for the horizontal and the effort in the vertical, and that's similar to we just do the work time relationship, and we can be able to do that in the next class when we assess, evaluate the project status and forecast in the future. I will go back to this slide, this real project report in next lessons. So with that one, we can be able to apply in problem 3 of today's lesson to understand the differences between planned value PV, earned value EV, and actual cost AC.